Welcome to all. I am Malarvali from CT department. The topic is algorithm and data structures. In this video, the topic which we are covered are history of algorithm, definition and properties of algorithm, characteristics of an algorithm, and what is meant by data structures and how the data structures being classified. First of all, the history of algorithm is to be discussed. So the father of the algorithm is algorithmy. It is depicted in the picture. So algorithmy is considered to be the first algorithm designer for adding numbers represented in the Hindu numeral system. The word algorithm originates from the Arabic word algorithm, which is linked to the name of the Arabic mathematician Al-Khwarizmi. And Al-Khwarizmi was a mathematician who wrote on Hindu Arabic numerals, and the word algorithm derives from his name. And the next one, definition of algorithm. So what is meant by algorithm? It is a finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of effort in a finite length of time. Next, the structure of the algorithm. So the structure of the algorithm consists of 5 main steps. The first one input, and the next one assignment, third one is decision, and fourth one is repetitive, and the fifth one is output step. So let us see one by one. The first step is we have to consider two operands, 987 for 76 for example, for addition purpose. And the next one is assignment steps. So you have to set the pair of digits from the two numbers and the previous carry digit if it exists for addition. And the next one is decision steps. So decides whether the added digits yield a value that is greater than 10, then we have to carry, that is, and so on. And repetitive steps repeats the process for every pair of digits. And the last one is output step, that is releases the output, which is 1063. So these structure of algorithm can be represented in the right side. So the numbers are 987 and 76. We are adding these two numbers. First of all, rightmost digit I should add. So first one, 7 plus 6, we have to get the value as 13. So 3 is in the place. Then we have to get the carry as 1. Next, adding 8 plus 7, that is inner digit. Then again we have to get the value, then carry 1. So this way is repeated again. So we go for an addition, then we come across the output as 1063. So in this method of steps may be first derived from the algorithmy, that is the father of the algorithm designer. And next one is what are the properties of algorithm? The first one is finiteness. That is, the algorithm must finite after a finite number of steps. And the next one is definiteness. It must be precisely defined or unambiguously specified. And the next one, generality. It is must be generic enough to solve all the problems. And the fourth property is effectiveness. That is the capability of producing a desired results. And then last property is input and output. That is, the algorithm must have input, intermediate steps, and required output. And then next topic is characteristics of an algorithm. So in the characteristics, the first one is well-defined inputs that the algorithm should contain. And it should be clear and unambiguous. And it should be the language independent. And it should be a feasible one. And it must have finiteness. So, and the last one is it has a well-defined outputs. So these are the main important characteristics of an algorithm. And the next topic is advantages and disadvantages of algorithm. So first one, advantages. The algorithm is very easy to understand and it is a stepwise representation of a solution to a given problem. In algorithm, the problem is broken down into smaller pieces or steps. Hence, it is easier for the programmer to convert it into an actual program. And the disadvantages of algorithm also available. So first one, writing an algorithm takes a long time. So it is very time consuming process. And the next disadvantages, branching and looping statements are very much difficult to show in algorithms. The next topic is classification of data structures. So the data structures may be classified into two main types. The first one is linear and the next type is non-linear. In the linear data structure, it will again divided into two, and the first one is sequential and the next type is linked. In the sequential linear data structure, arrays, stacks, queues, priority queues are the best examples. And the linked linear data structures, linked list, linked stacks, and linked queues are available. Then other category is non-linear data structures. So trees and graphs are main types of non-linear data structures. And then let us see one by one. First one, array. So array is a linear data structure and it is a collection of homogeneous data items stored in continuous memory locations. For example, if an array of type integer, then it can only store integer elements and cannot allow the elements of other types such as double, float, character, etc. So the above diagram represents an integer array that has 5 elements. The index of the array starts with 0 from array of 0 to array of 4. The memory locations are represented as 1000, 1004, 1008, 1012 and 1016. And the values which are residing in the array are 10, 20, 30, 40 and 50. So this is an array data structure. And the next linear data structure is stack. So stack means it follows a particular order in which the operations are performed. The stack order may be LIFO or FILO. So LIFO means last in first out, or ILO, that is FILO means first in last out. For example of stack is a deck of cards or a pile of plates. These two are represented in a pictorial representations. The stack operations may involve initializing the stack, using it, and then de-initializing it. The stack is used for the following two primary operations. There are two operations. The first one push and the next one pop. Pushing or storing an element onto the stack, and pop means removing or accessing an element from the stack. So these two primary operations are available in the stack for performing various operations. And then how to represent the stack? There are two main operations available. So first one, the process of putting a new data element onto the stack is known as push operations. So this consists of various steps. Let us see one by one. And the first step is check if the stack is full. If the stack is full means we have to produce an error and exit. Otherwise, we have to increment the top value to point to next empty space. And we have to add data element to the stack location where the top is pointing and return success. And in the same way, pop operation, accessing the content while removing it from the stack. This also contains various steps, and the first one checks if the stack is empty. And if the stack is empty, then we have to produce an error and exit. Otherwise, we have to access the data element at which the top is pointing. And we have to decrease the value of top by 1. And we have to return success. So these two way of stack representations available. And applications of stacks. So these are the list of applications available. And the first one, expression evaluation. So stack is used to evaluate postfix, prefix, and infix expressions. And the next application is expression conversion. An expression can be represented in prefix form or postfix form or infix notation. And the stack can be used to convert one form of expression to another. Third application is syntax parsing. That is, many compilers use a stack for parsing the syntax of expressions, program blocks, etc. before translating into low-level code. And fourth application is backtracking. Suppose we are finding a path for solving maze problem. We choose a path and after following it, we realize that it is wrong. Now we need to go back to the beginning of the path to start with new path. This can be done with the help of backtracking method, and parenthesis checking. Next application. So stack is used to check the proper opening and closing of parentheses. And the next one is string reversal. So stack is used to reverse a string. We push the character of string one by one into the stack, and then we have to retrieve one by one from the stack. And the next application is function call. Stack is used to keep information about the active functions or subroutines. Thank you.